Hello and welcome to this video in which we'll be solving a question on probability, and we will be using very basic geometric properties to find out the answer to a probability question. So sometimes what happens in very simple probability questions is that just using fractions can become a bit difficult because it is mathematically not possible to exactly quantify what is favorable and what is not favorable in terms of mere fractions. So sometimes representing the question in a geometric format and then using areas to calculate probability can be handy. So let's look at a question like that, in which this particular approach that I'm talking about can be a bit helpful. So the question is in front of you right now. I will give you 2 minutes to read. You can even pause the video right here and you can read the question. Once you get a sense of understanding of the question, let me also explain what the question is about. So there is one person, Kushal, who wants to travel between two cities, A and C. But there is no direct bus between A and C. The way that Kushal can reach from A to C is that first he has to take a bus from A to B and then from B to C. Now the bus that travels from A to B, it leaves at 4 p.m. and it takes exactly 2 hours. So the right time for reaching B for the first bus is going to be 4 p.m. plus 2 hours, 6 p.m. But sometimes what can happen is that the bus can arrive 15 minutes early, which means it can reach at 5:45 p.m. And similarly, it can be 30 minutes late, which means that it can even reach at 6:30. So anytime between 5:45 to 6:30, the bus from A to B can reach B. Similarly, the second bus which travels from B to C, its right time for departure from B is 6:15. But it can leave 15 minutes early. Sometimes it might leave 15 minutes early. So it can leave as early as 6 p.m. or it can leave sometimes even 45 minutes late, which means it can leave as late as 7 p.m. So which means that the second bus from B can depart anytime between 6 p.m. and 7 p.m. And we have to calculate the probability that Kushal will be able to board the bus from B to C, which means that he will be able to reach C on that day. That is what we have to find the probability of. Right? And the presumption is that the passenger or Kushal will be able to board the second bus as long as he reaches B at the time of departure or before the departure of the second bus from B to C. So if this is clear, then let's make a note of what exactly are the timings at which the first bus arrives at B and the timings which are possible for the second bus to depart from B. Now from here, if we try to apply fractions, and the problem is that it's very difficult for us to figure out, should I take the time in minutes or seconds or fraction of hours? And it can become a bit confusing in understanding how to approach the solution of this question. So let's try a simpler approach where we are using geometry. And what I'm going to do is that for that, I'm going to draw a graph. And in this graph, I am going to be putting the timings of the first bus traveling from A to B on the x-axis and the timing of the second bus going from B to C, departing from B to reach C on the y-axis. So the time at which the first bus reaches B can be anywhere between 5:45 p.m. and 6:30 p.m. So that is what is present inside the x-axis, and the timing at which the second bus can leave can be anywhere between 6 p.m. and 7 p.m. That is what is present on the y-axis. So once I draw this graph, I know that the area under consideration for us lies within this particular rectangle, right? Where the limits for the x-axis are between 5:45 to 6:30 and the limits for the y-axis are between 6 p.m. and 7 p.m. Right? So this is the total possible area in which the two events can happen. The two events are arriving at B and departing from B. Now let's see what part or what portion of this area is favorable for Kushal in order to catch the second bus. So firstly, this area, which is the area between 5:45 p.m. to 6 p.m. of the first bus reaching B, is absolutely favorable because anytime the bus reaches B between 5:45 and 6 p.m., Kushal will definitely be able to catch the second bus because the second bus leaves earliest at 6. So even if Kushal reaches at 6, even that will be favorable for Kushal to catch the second bus, and anytime before 6 is also favorable. So the region which lies between 5:45 to 6 p.m. of the first bus arriving is completely favorable. Similarly, the second region which is absolutely favorable is if the second bus departs after 6:30. So anytime the second bus departs after 6:30 p.m., Kushal would have definitely reached B by that point of time. So the entire part of this graph, which is the second bus leaving after 6:30 will be favorable. This will also be a green region. Now we are left with the one single rectangular region or square region, in fact, in which there is a possibility of Kushal reaching the bus if the first bus reaches later than the second bus departs. So in a part of this rectangle, the second bus leaves only after the first bus arrives, but there's also part of the rectangle where the second bus leaves earlier than the first bus arrives. So what we are trying to find out is that which part of this area has the value of x-axis less than the value of the y-axis, because the value of the x-axis is the time when the first bus reaches B, and the value of the y-axis is the time at which the second bus leaves B. So of course, the timing at which the second bus leaves B has to be greater than the timing at which the first bus reaches B. So the x value has to be lesser than the y value. That region will be favorable for Kushal. So what I can do is that if I draw the diagonal of the square, the diagonal is that particular straight line which represents x is equal to y. So above the region x is equal to y, y will be greater than x. Below the region x is equal to y, the region will be x greater than y. So if I draw the diagonal, the region below the straight line, which is x is equal to y, will give me the region where x is greater than y. And in this case, Kushal will miss the bus. But in this region, y will be greater than x. In this case, Kushal will be able to catch the bus. So the half of the square, the right angle triangle, which is present above the x is equal to y line, will be favorable for Kushal. So the total probability of whether Kushal will be able to catch this bus from B to C on time or not is going to be the sum of the areas of the green regions divided by the total area. So the favorable regions area can be calculated like this. The first rectangle has a length of 0.25, has a breadth of 1. So its area is 0.25 into 1. Similarly, the second rectangle on top has got a length of 0.5 and a breadth of 0.5 as well. So 0.5 to 0.5, 0.5 square will be the area of the second rectangle. And the area of the third triangle, which is a right angle triangle, will be half into base into height. Half is 0.5. The base of this right angle triangle is 0.5 and the height is also 0.5. So 0.5 into 0.5 into 0.5 will be the area of this right angle triangle. So the three areas put together will be 0.625, and this is the favorable region for Kushal to catch the second bus. And the total region's area will be the entire rectangle's area, for which the length is 0.75 and the breadth is 1. So 0.75 into 1, the total area will be 0.75 into 1. So the probability that Kushal catches the bus will be 0.625 by 0.75, which will be equal to 5 by 6. So that is the answer of this question. And these, or cases like these, can be places where you can look at applying geometric areas in order to simplify questions of probability. Thank you.